A force F is equal to 20 plus tan y acts on a particle in y direction, where F is in Newton and y in meter. Work done by this force to the particle from y is 0 to y is 1 meter is. Work done will be equal to F dy limit 0 to 1 meter. 20 plus tan y dy 20y plus tan y square by 2 0 to 1, 20y plus 5y square to 1, 20 into 1 plus 5 into 1 pi square minus 20 into 0 plus 5 into 0 pi square. This is 25 joule. So work done will be 25 joule. B is correct option. Next, when a block of mass m is suspended by the long wire of length L, the length of wire becomes L plus L. The elastic potential energy in the extended wire is. Wire length L. इस पर हमने m मास का एक ब्लॉक सस्पेंड किया, तो दिस एक्सटेंड्स स्मॉल l डिस्टेंस. Initial restoring force is 0. Final restoring force weight will act downward mg and restoring force F will be upward, and this F will be equal to mg. Average restoring force is 0 plus F by 2, 0 plus mg by 2, mg by 2. Extension is L. So work done against restoring force will be stored as potential energy. So P is stored, work done against restoring force. Average force into extension mg small l by 2. This B is correct option. Next, body A of mass 4 m moving with speed u collide with another body B of mass 20 m at rest. The collision is head-on and elastic in nature. After the collision, the fraction of energy lost by the colliding body A is. body A, इसका mass is 4m and initial velocity is u. This collides another block B of mass 2m और इसका initial speed is 0. After collision, this m a, इसकी velocity suppose v1 and velocity of b is v2. Conservation of momentum, final momentum will be equal to initial momentum. Final momentum is 4m v1 plus 2m v2 is equal to initial momentum 4m u1 plus 2m u2. 4m u plus 2m into 0, 4m u. 4m v1 plus 2m v2. 2m से बोथ साइड डिवाइड कर दिया तो v1 plus v2 is equal to 2. Equation number 1. Collision is head-on and elastic, hence coefficient of restitution E is 1. So E is velocity of separation upon velocity of approach. This is U. Velocity of separation is v2 minus v1 and this is u1 minus u2. This is 1. v2 minus v1 upon u minus 0. v2 minus v1 is equal to u. Equation number 2. v1 की वैल्यू कैलकुलेट करनी है तो इक्वेशन नंबर 1 से इक्वेशन नंबर 2 को सब्सट्रैक्ट किया तो 3v1 विल बी इक्वल टू u and v1 is equal to u by 3. Now this is u by 3. तो इनिशियल काइनेटिक एनर्जी ki half 4m u square is equal to 2m u square. Final kinetic energy 1 into 4m u by 3 का स्क्वायर 2m u square by 9. Fraction of energy lost. Initial minus final kinetic energy divided by initial kinetic energy. 2m u square minus 2m u square by 9 upon 2m u square. This comes 8 by 9. Hence A is correct option. Next, an object flying in air with velocity 20 I cap plus 25 m j cap 25 j cap minus 12 k cap breaks into two pieces whose masses are in ratio 1:5. The smaller mass flies off with a velocity 100 I cap plus 35 j cap plus 8 k cap the velocity of larger piece will be, suppose एक m मास का ऑब्जेक्ट मूव कर रहा है वेलोसिटी v से, वेलोसिटी गिवन वेलोसिटी इज, सपोज दिस इज v1, इसका मास सपोज m और वेलोसिटी इज v1. इसका एक पार्ट स्मॉलर पार्ट, इसका मास विल बी m/6, ये v2 वेलोसिटी से मूव करता है, दिस इज v2. सेकेंड लार्जर पार्ट, फाइव m/6 moves with velocity v3. मोमेंट कंजर्वेशन, लीनियर मोमेंटम कंजर्वेशन से फाइनल मोमेंटम is equal to initial momentum. Final momentum is m/6 v2 plus 5 m/6 v3, that will be equal to mv1, or v2 plus 5v3 will be equal to 6 v1. 5 v3 is equal to 6 v1 minus v2. 6 20 I cap plus 25 j cap minus 12 k cap minus v2 is 100 I cap plus 35 j cap plus 8 k cap, or 20 I cap 115 j cap minus 80 k cap, or v3 will be 1/5 20 I cap plus 115 j cap minus 80 k cap, 4 I cap plus 23 j cap minus 16 k cap. तो थर्ड की वेलोसिटी होगी 4 I. This A is correct option. Next, a particle of 5m at rest suddenly breaks into two fragments of mass m, each move along mutually perpendicular direction with each speed v. The energy released during the process is, suppose this 5m is at origin, this is 5m, और initial velocity of this is 0. एक जो x एक्सिस y एक्सिस, सपोज एक x एक्सिस की तरफ जाता है, इसका मास m है और इसकी वेलोसिटी V2 is V I cap. V I cap. Second part goes in direction of y. इसकी velocity is v3 v j cap. And third one goes in a direction और इसका mass is 3m और इसकी velocity is v4 I cap. तो moment conservation, initial momentum conservation. So initial linear momentum will be equal to final linear momentum. Pf will be equal to Pi. P final is m v2 plus m v3 plus 3m v4, and this will be equal to 5m v1. 5 into v1 is 0, this is 0, or v2 is v2 plus v3 plus 3v4 is equal to 0. v2 is v I cap and v3 is v j cap plus 3v4. So v4 will be equal to minus v by 3 I cap minus v by 3 j cap. So magnitude of v4 will be minus v by 3 का square plus minus v by 3 का square under root v root 2 by 3. Energy released will be half m v2 का square plus half m v3 का square, इसका magnitude का square plus half 3m into magnitude of 4 vector का square. 1 by 2 mv square plus 1 by 2 mv square plus 1 by 2 into 3m into v root 3 by 2 by 3 का square. mv square plus 3 by 2 m into 2v square by 9. mv square plus mv square by 3, 4 mv square by 3. Energy released होगी, that is 4 mv square by 3. This D is correct option.